So hello guys, welcome back to Gettobyte channel once again. So continuing with the series of timer input capture peripheral in STM32 controllers. Now in this video we are going to start with a bare metal driver and coding for timer input capture in STM32 microcontrollers using PWM input mode, which I have told you in the previous video, the register descriptions and about its details. So guys, now we'll be using the STM32 Cube ID for writing a project, bare metal project on STM32 F103 controllers. I have already created the bare metal project, and you can also check out our video on how to know that how do we have to create the empty project without using any STM32 HAL on the STM32 Cube ID for the STM32 microcontrollers. I have already created it, and that's the by the project name STM32 F103 timer input capture bare metal, and this is my main file. Now in the main file you will see that under the while function I have written the very less code, like just enabling the timer for channel 1 capture and unconfiguring it so that for delay of 4 seconds, so that you can check out in the we can see the frequency, the external signal is being captured in every 4 seconds. Now the main functions and the main files which will be there are the gv timer input capture.c and the gv timer input capture.h, which will be having all our functions. For configuring our timer 4, we will be using the timer 4. So we will be using the timer 4 for our input capture mode. Okay, and the first thing, now we will start writing the bare metal driver. And the first thing that we need to do is we need to configure the pin which we will be using for our input capture mode. So as I have told you in previous videos also, that I will be using timer 4 channel 1, that is PB6 pin will be used as my input capture mode. Now in the case of input capture mode, it will be getting some input. The pin will be acting as an input mode. So we will be configuring it as a floating input pin. Okay, and we will just enable the RCC peripheral clock of our GPIO-B port. Okay, and then using the GPIO-B registers of CRL, because PB6 will be lying under the CRL, out of the CRL and CRH, it will be lying under the CRL. For understanding this thing, you can get to know about from the above video in which about the GPIO peripheral in STM32 microcontrollers, in which I have properly told on how to configure the pins for input and output. So here the pin thing is simple, that we have configured PB6 as the floating input pin. Now comes the next part in which we actually start coding, configuring our timer peripheral for the input capture. Okay, so the starting of this part will be starting. First we will make sure that our timer is disabled, because we will be now configuring our timer parameters. So before configuring, it should be make sure that our timer is disabled. Okay, so first we will be disabling using the timer CR1 register in the CEN bit, which will enable the counter timer, so that is set as low. Then we will reset and enable the peripheral clock of the by the RCC peripheral of the timer 4. The timer 4 lies at the APB2 bus, so APB1 bus. So we will be setting that pin of the timer 4 EN on the in the RCC underscore APB1 ENR register. You can get to know about this thing from the RCC peripheral and then RCC registers and then the APB1 ENR. Okay, so here you can see that in the RCC underscore APB1 ENR, my timer 4, the bit 2 signifies the timer 4. So we will be setting that pin to 1, so that timer counter is enabled. Its peripheral clock gets enabled. Okay, then comes the next part. In the next part, we will be going and configuring our timer to the more things. Okay, so now, and yeah, after the RCC peripheral, like the timer peripheral is on, we will call this the function which will configure my pin, the capture input capture pin. that I have configured over here. Then next thing that we'll be doing is the basic configuration. As I have told you in the register description, that PSC and the ARR registers will be playing an important role, in which PSR, the prescaler register, it would be telling us about the timer peripheral clock that it will be input to it from the core clock. So I have set PSC as 32 so that I can get the timer clock as 1 megahertz, as my FOSC is equals to 32 megahertz. Then timer for ARR, this will signify the minimum frequency that I can capture the output signal with minimum frequency that I can capture. So I have set that as 65535. So my minimum frequency is around 15 hertz. Another thing is that the timer for time underscore ARR, it can have the maximum value of 0x FFS, that is 6535. And you can see that minimum frequency is directly proportional to the timex clock, and now timex clock is are directly proportional indirectly proportional to the value of the prescaler. Okay, so we can also say that the minimum frequency we can vary by varying the value in the prescalers and making the ARR constant, as ARR has the maximum value of 65535. That is the number of counts that the counter will count from before getting reset or after getting the reset. Okay, so and then like this PSR and ARR are the shadow registers. So once we've assigned these values, now to actually update these registers, there is a small procedure that we have to follow in STM controllers, that this UDIS bit has to be set low and then interrupt has to be generated so that our registers are updated. So that's what I have done over the 50 and the 52 line. So that my prescaler and the ARR value, that is timer clock frequency and the minimum frequency the timer can capture, that both are configured. Then comes a timer clock configuration. Okay, now as I have told you that in the register descriptions, that the register CSMCR, wait, that the timex underscore SMCR registers, so its first or these yellow bits will all be set to 0. Okay, because we are not using any we are not using any external clock, we are not using any external trigger. Our trigger is the internal pin only. Okay, that will be getting the value from the external signal, but our trigger is the internal pin, that is the PB6. So our external trigger prescaler is also disabled and all those things. The only bits, so that is why the timer clock configuration in this SMRCR, all these bits have been set to 0. Okay, as you can see over the line number 16. Then comes our timer slave configuration. Now as I have told you, in the SMCR register, all these bits will be 0. Only TS and the SSMS bits will be used. TS pin set for the trigger selection, in which it would tell that what is the trigger input. Okay, so now our trigger input is filter trigger input 1, that is the input at the TI1. So we will set the trigger selection as the TI1 filter trigger input, so 101. So that's what I have done over here. Bit 2 and the bit 0, 2 and the 0 have been set to 1. In the SMS slave mode selection, it is set as reset mode. In the previous video, I have explained you why that I have used this thing. Okay, why we'll be using the reset mode in the okay, because we have to on the rising edge of the intern of this trigger, okay, of the TIX pin, we have to initialize the counter so that it can the counter value can have fresh value when it detects the another rising edge or the another falling edge. So this will be set to 100, and thus my bit 2 is been set to 1. Okay, and then now we will be configuring our channel 1 and the channel 2. So that's it for now. Like the video, subscribe the channel and press the bell icon to get notified for new videos, and share it with your friends.